right, let's get started on our other type of charts. These are actually not mean charts, they're range charts. These are still for variables. These are things we measure. Range charts complement mean charts. So hopefully you looked at the other video first. You saw how to do an X-bar chart when we knew the standard deviation of the process and when we didn't. So we started to see range appear, but we weren't really measuring range. We were really measuring the mean of the samples. In this case, we are actually going to measure the range, and then I'll explain why. So control charts for variables, mean charts we get. The other one is a range chart. Specifically, we'd like to know if we took a sample of 10 cups of coffee and we measured the temperature of all 10, we'd get the mean temperature, which would be the X bar, and let's say it's 179, which is pretty awesome because our target was 180 and it was within our upper and lower control limits. But think about this. If our sample of 10 cups of coffee, one of them was 300 degrees and the other one was 50 degrees, the average would still be okay, but somebody's getting burned and somebody's getting cold coffee. So we need to look at both range charts and mean charts. So the range would say, take all 10 cups of coffee, measure the temperature of all 10 cups of coffee, but for your sample, for your control chart, just look at the hottest and the coldest cup of coffee. How many degrees differences between those? Is that an okay range? And you can see that there can be some odd cups of coffee that can really be dangerous to our process. And so your range could indicate that your process is out of control, or your mean could indicate, or neither one could. So we need to actually check both. There's a little different formula that we use for this. Make sure I get my pen working correctly here. You recognize this little strange characters here, D_4 and D_3. Those come from that table that we talked about in the last video. That's a standard table in statistics. So we'll use that again. Let's try this problem, jump right into it. Eagleton electric motors are used in cars. The manufacturer wants to ensure that the motors reach the expected speed. Using several samples of 8, n equals 8, watch for those little things, sample size, n equals 8, they determine that the sample range is 3.25. Based on this data, develop an R chart, a range chart they can use to monitor the quality of the process. So we're going to try to figure out what the appropriate upper control limit and lower control limit would be. We would like to be 97% confident. Now I want you to start to see these other things, because when you see 97% confident, that translates to a Z of 3. So if you see either one of these, Z3 or 97, then the Z is 3. So let's put together our little problem here. Get to my notes so I actually use the right one. I'm going to write down the formula. Upper control limit from the prior page should be D4, so I've got to go to the table and get the value, times R bar. And the lower control limit, give yourself a little space here, is D3 times R bar. So we know what R bar is. It's 3.25. So we can substitute that in. And all I need to do is go to my table and get my D4 value. My D4 value for a sample size of 8 is 1.864, and my D3 value is 0.136. So I'm going to take these two values back to my formula, substitute in my D4 value of 3.25. Oops, sorry, a little technology problem here. 3.25, my little operator problems actually. And, sorry, that was not, let me get my eraser here, my handy dandy electronic eraser. The value from the table was actually 1.864. The D3 value from the table was 0.136. I'm just going to multiply these together, and I'll come up with 6.058 down here, multiply these two together, I'm going to come up with 0.442. So now my upper control limit should be 6.058. My lower control limit, 0.442. My mean range is 3.25. And again, as I like to say, we're off to the races. We'll go take our sample at 9 a.m. We will take our sample of, let's say, 10 motors. We'll run them up and see how they do. We'll find the highest and we'll find the lowest. We'll subtract the two. We'll get the sample range and we'll post it on here. 10 a.m. We'll go out and do the same thing. We'll do our sample, find the highest, the lowest, subtract the two, and we'll put them in there. So very different scenario, range and means, but they work together. I go over here. This picture is terrible, but the point being, and please hear me, people do this all the time. They do sampling and they get fixed on on mean, because mean is so obvious and so comfortable. And they say, oh, we've been taking mean samples and everything's running great. And I come into them and say, you better check the range, because the mean can be fine and the range can be out of control. They need to both be in control. You have to measure both. And the official terms are central tendency is what is mean, and dispersion or spread is the range. And so we have to be really careful. Here's an example where the X bar chart is out of control, but the range is in control. We've got to watch them both. And here's the opposite situation. So either one can happen. You have to monitor both, not just one or the other.